hey there. I'm just here combing the hair off my cat. But I'm thinking to myself, how does this hair come off? I mean, there's a lot of it. There has to be some way. And then I realized, it's friction. Right? Everyone always hears that word friction, but you may not know what it means. Friction is a force between two objects when they rub together. For example, my hand and this cat. As a result, the force rips off clumps of hair. Also, there's friction that causes the pain, the force that causes the pain between his claws and my leg. It's friction that's keeping me on this chair, otherwise I'd slide right off. And it's friction keeping everything still. Friction keeping that camera still. If it wasn't for friction, everything would just be sliding around. But if it wasn't for friction, I wouldn't have cat hair everywhere. Now, since friction is everywhere in our daily lives, I've had my friends do a couple demonstrations, ain't that right, Cat? About friction. How friction's everywhere, you know, sleds, cars, tabletops. Well, we didn't do any tabletop experiments actually, but you get the point. Friction's everywhere. Watch these experiments.
In this experiment, we slid two identical pucks along two different surfaces. The surface on the right is a polished wood surface, while the surface on the left is a carpeted surface. As you can see, the puck slides farther on the wooden surface. This is due to its low coefficient of friction. In the second portion of this experiment, we decided to slide a large cooking pot across the wooden surface. This experiment shows the effect that mass has on friction. As the mass of the object increases, the force of friction increases as well. When mass is added to the object, the static friction of the system increases, thus requiring more force to get the object to move.
In Canada, curling was a massively popular sport and the nation had high expectations of Olympic gold.
I don't want to be an outtake. You guys all suck.
Think about when you ride a sled down a hill in winter. Why are you able to just slide all the way down the hill? Wouldn't friction stop you? Well, to demonstrate this, let's first see what happens when you try to sled down a hill in the middle of the summer. The reason I wasn't able to go down the hill was because of friction between the sled and the grass. You can sled down a hill in winter because of the snow. The snow has less friction than grass does, allowing you to ride down the entire hill, no problem.
As you can see here, you need friction to play tennis. Without it, you would essentially be ice skating. You need friction to hit the ball needs friction to bounce after you hit it, and air exerts friction on the ball as air resistance to slow it down. As you probably know, the ball requires friction to be hit, and without it, the ball will just fall to the ground. Also, air resistance slows the ball down after it is hit. The surface of the court, or more specifically, the coefficient of friction of the court, affects the manner in which the ball bounces off of the court. A clay court will slow the ball down after the bounce due to the high coefficient of friction, and the grass court will speed up the ball, to an extent. A normal concrete court, like the one here, will not affect the speed of the ball very much. You had one ball. Many of you might have seen the tachometer on the dashboard of your cars. The tachometer is the gauge that measures the speed at which the components inside the engine rotate. The red line on the tachometer is not meant to be crossed ever. This is because if the engine rotates above this speed, the parts will lose the friction that holds the components together, and then the engine will explode in a magnificent fashion. If engine speeds past the red line are sustained, bad things will happen.
In this scene, you can see smoke and hear screeches caused by the friction between the car's tires and the pavement.